All right, for this, this is week, well, what is this week? Let's see, April 20 to 24th week. And this would be assignment number 2. Assignment number 1 was the Monopoly assignment. Should have been an easy peasy assignment. Hopefully you had fun with that. I'm going to show you guys, I'm going to basically do most of this with you, and you're going to submit your work when you're finished. I'm going to show you how you can do this on paper. I think some of you guys are getting frustrated with the technology, but some of you guys like using technology. So you can do this either way. I'm going to post this in a Google Sheet, and you can also, I'll have a PDF of this. You could just print this if you guys have access to it. If you don't have access to a printer, but you want to just do this on notebook paper, you could do that as well. So you have an option of doing this on paper or on your computer. And I'm going to show you both ways. You already know on your computer how to make a scatter plot. So what you can do for that online is I will have this posted in a Google Sheet. You can go ahead and make a scatter plot. You know how to do that. But just to, if you are going to do one by hand, you always want to make sure you put this on the x-axis, March temperature in Celsius, and you kind of just skim through the numbers, and the highest number, maybe a 6.2. So I skipped a space and went up to 7. And then this is dealing with April date. And what this is a cherry blossoms. I know they have some at Bowling Green State University for anybody going up there next year. But they're also in Washington, D.C. If you guys have ever been, they're like a beautiful flower that blooms on a tree. So let's kind of think what happens. If you have a warmer March, what do you think would be true of when flowers bloom? They probably are going to bloom sooner. So the higher the temperature, we would expect the quicker they're going to bloom. So I've done the first 3 dots. I'll make this go fast here and just
show doing the rest of the dots. So 2.619, 4.214, just kind of do the best you can. 4.714, 4.914, 421, seems kind of high. 4.99, 3.814, 413, 5.111, 4.313, 1.528. So this year they had to wait all the way to the end of April before they could see the cherry blossoms bloom. 3.717, 3.819, 4.510, 4.117, 6.13, 6.23, 5.111, 5.6, 4.69, and finally 4.11. So this was data collected over 25 years. So like this would be 1 year this happened. They bloomed on April 28th. A different year this happened. They bloomed on April 11th or whatever it might be. Okay, so we definitely see a downward trend. It's not perfectly 1 year, but it is pretty close.
So the direction and strength, you would say a negative slope. And the strength, you probably use the word moderate. It's not super weak, but it's not really strong either. So it's kind of in the middle. So negative, moderate. Okay, find the best fit regression line. That we can do in Schoology, but we also can do that on our calculators. I've already entered my data into list 1 and list 2. And now if we go to stat, calculate, number 4, see how it says linear regression? List 1, list 2, yep, that's what I want. And here's going to be our linear regression equation. So y equals negative 4.7x. So do you guys see the A is the slope and the B is the y-intercept? This is a positive, so I'm going to say plus 33.1. Okay, a lot of you guys struggled with the slope. A lot of you guys were missing points at describing the slope. This is the slope and this is the y-intercept. So the slope is negative 4.7 over 1. I think that 1's helpful. You always want to use a 1 in your sentence. Remember, slope is like rise over run. So you're going down 4.7 over 1, down 4.7 over 1, down 4.7 over 1. So you're going down in the April date, but your 1 is your increase in temperature. Okay, so here would be our sentence. So as the March temperature increases by 1 degree Celsius, the bloom date decreases by, and we'll label this days, 4.7 days in April. Okay, and we did not talk about the y-intercept last week in Monopoly because it kind of didn't make sense, but now I think we can kind of make sense of it. So our y-intercept is 33.1. So this is, this would be 32. So 33.1 would be, I'm going to make this in a color, would be around here. Okay, and then I could do my slope down 4.7 over 1. I mean, I could kind of measure that, but I'm just going to kind of draw my best fit line. Okay, so let's think of what this means right here. What does the y-intercept mean? So if it's on the y-axis, what number is 0? The March temperature is 0. So that'd be a really cold March. So if you had a really cold March where they only average 0 degrees in March, this would be the date of the first bloom. So the y-intercept, I think it's helpful to write it as a coordinate, 0, 33.1. So the 0 stands for March temperature. So if March temperature is 0 degrees Celsius, the first bloom will happen 33.1 days. Now, what does that mean, 33 days? There's not 33 days in April. There's 30 days in April. So it's actually like they wouldn't even bloom in April. That would be 3 days even later. So I'm going to write in parentheses, that would be like May 3rd. So I know that's something's kind of weird. And all you really have to do is copy this down and put this in your project. Remember to answer this question. Okay, on the back, here's just like an example. So the average March temperature this year was 3.5 degrees. When would you predict the first cherry blossom is? So I'm just going to write our equation again, so I don't have to keep looking at my other page. So it's negative 4.7x plus 33.1. Degrees Celsius is an x. So make sure you plug it in here, and you don't forget your 33.1. That was kind of a common mistake last week as well. Okay, let's find, so you need to finish that problem. Make sure you label your answer, please. What does your answer mean? Has something to do with the month April. Okay, number 4, find the residual for the year the March temperature was 4.5 degrees. Okay, so if we look back at our data, right here is our 4.5 degrees. So 4.5 degrees, the first bloom was 10. Okay, so the actual first bloom was April 10th. But let's see what the predicted first bloom was. This is what happens when you plug in 4.5 in for x. So go ahead and plug your 4.5 right here in for x, and that's going to give you your when you would expect the first bloom to happen. So put that date there. Okay, and then the residual is going to be how far off we were. It's going to be the actual number, so it'd be 10 minus whatever this number is. That's going to be our residual, and remember, that's like an error. And I know you did that last week, so make sure you finish those 2 problems. Okay, question number 5. This is something new, and I'm just going to teach it to you as we do this problem, and I'm going to show you how to do this using your calculator, but you can look at my calculator for right now. If your calculator's dead or you don't have one, I'll show you guys in a separate video how we could have done this on Google Sheets. Okay, so question 5, run a hypothesis test to determine the March temperature is a good predictor for April cherry blossom. So if we go to stat and go over to test, we've almost done every test. But if you look down to, is it at the very bottom? Yeah, it's all the way down, letter F, linear regression t-test. Linear regression t-test, that's what we're doing right now, is a linear regression. So on your calculator, this is letter F on your calculator. Okay, so let's talk about our null and our alternative hypothesis. I know you guys remember doing these. We're not talking about means, we're talking about slope. So here's the symbol. This B with like is beta, it's got like a long line right there. That means slope. I think it's actually a B1, so we'll put a B1 there. If your slope is 0, you guys remember how I had you guys do, like pick your, like the worst case scenario, like your R level is 0, that means there is no relationship. Okay, but if we think that the cherry blossom situation, you know, is a negative relationship, right? We expect that it's a pretty strong negative relationship. So if you think it's negative, you put a less in. We think the slope of this relationship is negative. So there's your null and your alternative hypothesis. Your null is always just means that there's no slope or there's no relationship. B1 equals 0. For this graph, we think it's less than 0. So this would mean a negative relationship. And again, you go to F on your calculator, okay? So if we go to letter F, and now you'd have to have all this entered in your calculator for it to work. So don't just go to this and say, mine didn't show numbers. You have to have list 1 and list 2 in there, okay? And then there's that weird Greek letter B, and we want to do the less than and hit calculate. Okay, here's our t value and here's our p value. So our t value is negative 7.6, and our p-value is really, really, really small. Look at the end of that. See the e negative 8? Our p-value is 6.8 times e negative 8, which really means like 0.000 blah, blah, blah. Does that make sense? So if p is small, what do? We reject the null. So write that in there. And what does that mean? That means that this second statement is true. And I'm going to write the sentence for you. So right in here in this box, I want you guys to write reject the null. And we're going to say there is a significant, and then since we did a linear test, you have to write actually I'm going to say negative linear relationship between, and then you name your two variables, March temp and April bloom, we'll say. There is a significant negative linear relationship between, and you name your two variables. You also can do a confidence interval for the slope. So remember our slope is negative 4.7. So again, if we go to stat and over to test, I'm gonna do the up arrow. Ooh, do they not let me do that? Do we have a linear regression interval? Oh yeah, letter G. Letter G. So linear regression interval, again, list 1, list 2, 95. And in our parentheses, we're going to write negative 5.9 or 96 to negative 3.41. Negative 5.96 to negative 3.41. So notice that's centered right around our slope. We think it's negative 4.7. So this is what it looks like as a confidence interval. And basically we just think the true slope. We are 95% confident. And on this line, right, the true slope is between negative 5.96 and negative 3.41. And see how that agrees with this? We think there is a negative relationship. Yeah, we think that it is a negative slope somewhere in that range. So you need to fill on this line, fill in this blank, and I'm going to do a quick separate video if you are interested in doing this all in your computer instead. But I think a lot of you guys are going to choose to probably do this on paper.